What's up people, and welcome to my tutorial in Pragmatic Data Science. So in this tutorial we're going to take a look at Pearson correlation, which is the linear relationship between x and y vector. So for the Pearson correlation of x and y, we are going to do the covariance of x and y over the standard deviation multiplied for the x and y vector. So let's start by taking a look at this covariance part here, what that is. And the way to calculate covariance is that you would take the for each element I in x minus the average value in x multiplied by the same thing for y. You will multiply them together and then sum them up over n minus 1. So the covariance basically works like this. So if you have two dimensions here, x and y, and as x increases, y also increases. So you're going to have a value that looks like this. It means that you're going to have a large positive covariance. And if you have the opposite situation where as x increases, y decreases, you're going to have a covariance that looks like this, which is going to give you a large negative covariance. And you can also think of something in between where there is basically no covariance between them. There is only random numbers here. Then that means it's going to give you near zero covariance. So it's a measurement of how equal these vectors, in a way, how they correlate to each other, how the covariance is basically between them. And that is going to be for the top section here. It's going to give you some value, and then you're going to divide that with this section here, which is a small sigma of x and y, which is a standard deviation. And the standard deviation works like this. So one standard deviation is if you have the mean value of the data set right here, one standard deviation means that 68% of your data is going to be within this section right here. And for two standard deviation, 95% of the data is going to be contained here. And for three sigmas or three standard deviation, 99% of your data is going to be within this deviation from the mean, which is here in the middle. So that's what the standard deviation does for you. And the way you would calculate the standard deviation for a vector is in this sense. So if you have n elements, and in this case n is going to be the length of your vector, you're going to take 1 over n minus 1 for this section here. And then you're going to do, if you have the vector a, for each element in vector a, you're going to take the value minus the mu, which is the mean value of the data set, which is calculated like this. So it's just the mean value, basically. You're going to minus that and the absolute value of that squared. So you get a distance from the mean squared. And then we take the square root of that in order to compensate for this exponent here. And as I said, the mu here is just calculated as the mean value of the vector A, like this. So it is pretty straightforward. And that is going to give you the standard deviation of the vector A. So if you go back now and take a look at this, you do this for vector x and you do this for vector y, and then you multiply them together, and then you get the linear relationship if you divide them like this. So fairly straightforward. So I think that is all for Pearson correlation, and in the next video we're going to take a look at something called Jaccard coefficient. Don't forget to subscribe, and if you have any comment or questions or remarks, leave it in the comment section below and I'll try to answer them. Alright, see you later. Bye-bye.